Hello everyone, we're live. Hello and welcome to the channel. I'm your host Stefan Burns, geologist, geophysicist, space weatherman, just another person on this planet, cosmic bro. We're here to talk about a lot of things today. We're going to do a complete space weather update because we have a lot happening over the next few days. So I want to have this done so you guys know what the energetic conditions are like right now for the next few days likely. We could get some changes. If they're significant enough, you know I'll update you as soon as possible with a video or a live stream. And we're also going to talk about 3i Atlas, this interstellar thing flying through our solar system, as we've been discussing a lot, because there are some new updates, and we have a second coronal mass ejection that the sun launched right to it. So we had that gigantic coronal mass ejection launch towards Venus and 3i Atlas on the 21st of October, which was the superior conjunction of 3i Atlas as viewed from Earth. So it was also a new moon. So we had the Earth, the moon, the sun, 3i Atlas on the other side. We've been forecasting for there to be enhanced solar activity and just in general enhanced energetic activity across the solar system, specifically in the inner solar system, basically ever since we first observed 3i Atlas, because before that we've been tracking comets and other objects and how they seem to influence the electrodynamics of the solar system. Well, right on that superior conjunction, the key date that we looked at in addition to the perihelion on the 29th, the closest approach to the sun, boom, we got that gigantic coronal mass ejection, one of the largest of this solar maximum period and of solar cycle 25, which has been stronger than NASA expected. We're having some weird things with NASA right now. So we had that first gigantic coronal mass ejection. We had a second one follow up that was also quite strong, not as big, but still a big explosion on the sun. Their stereo A camera, which is positioned so we can see that section of the sun, is missing the footage from both of those explosions. Why? Don't ask me. But we often see when there's really big energetic events, like the footage gets clipped. So I'll show you that. Also, we're still waiting on the NASA imagery of 3i Atlas from their NASA Reconnaissance, their Mars Reconnaissance orbiter. The high-rise camera specifically should give us a good look at it. And they've even updated the website saying, like, no 3i Atlas imagery will be released until the shutdown is over. So they clearly had the time to update the website, but not to actually just release the freaking imagery. So yeah, there's this kind of weird things in general. Like, you know, we're thankful for all the hard work of many of those individuals there. But when something smells a little fishy, there's something there, you know? There maybe it's just a few people that have the smell of fish to them. I don't know. But there's some weird stuff at NASA. And I've noticed this now for not just 3i Atlas and this whole story. I'm not trying to make a news story out of this. There's just always been like a little weirdness there. So we'll discuss that a little bit. And we also have a ton of comets in the inner solar system. So we've been discussing this, but right now, we are basically surrounded by comets. So check this out. We have our Earth right here. And I think this is set for today, but yeah, that was set for today. So here we have the Earth, okay? And here is 3i Atlas, which is our interstellar object. We see that quite clearly. And we also have two other comets, well, three other comets. We have C2025 A6 Lemon, and we have C2025 R2 Swan. Swan already performed its perihelion. That was on September 12th, and it was at about 0.5 astronomical units. We discovered it, I think, one day before or one day afterwards. So pretty much it happened. We saw it. Boom. Also, wow, we just had a really big super chat come in. So thank you so much, Youper, for the incredible super chat, super sticker, whatever you want to call it. That is awesome. Thank you. We have a very lively community here that all works together. We're all on board, and we just want to understand what's happening without the misinformation, the drama, but we're open to new ideas and to speculating a little bit. But also, when there's hard facts, we want hard facts. That's at least what I want. I want to have some fun in life, right? We want to have fun and enjoy things, but we also don't want to live in Delulu land, okay? So you can do both. It's not even a tightrope. It's really just like applying a little bit of logic, but also keeping other parts of your brain open to what is more. And this is one of these things. So you could just look at this and be like, oh, well, okay, so what? There's comets in the inner solar system. Well, we know that there is much, much, much more that we do not know than we do know in terms of all of human knowledge, okay? We also know that a lot of that stuff that we don't know even know we don't know, okay? That's actually probably the vast majority of that. So to say that we've only been tracking this stuff for, you know, centuries, because sunspot observations go back like 400 or 500 years. But in terms of like good stuff nowadays, like past, basically space age up to now. So from 50s to now, we've had really good equipment, digital technology, all that sort of stuff. We've been tracking this for almost no time at all. Electromagnetism came online with Maxwell's equations. I mean, we were experimenting with it, and Ben Franklin was flying his kite before that. But really, our understanding of electromagnetism is fairly recent in human history. Now, there is evidence going further back, but that's a whole different conversation. So to say that we don't, like, we know that these comets are just flying in and not doing anything, I think that's a little preemptive. So we have Atlas here. We have R2 Swan really close to Earth, as you see, ready to perform its perihelion. It's now zooming away. We have K1 Atlas about to perform its perihelion. That will be on December 31st at 0.33 astronomical units. So it will get the closest actually of all these comets. We see that perihelion right there. Gets within 0.33 astronomical units. The distance from the sun to Earth is 1 AU. So it's pretty close. And then the star of the show right now, in terms of actual viewability and such, is A6 Lemon, which has its perihelion on the 8th of November at about 0.53 astronomical units. So if we go forward here, you'll see how it's getting closer and closer, just like that. So, and it's actually showing K1 Atlas zooming away. Did it already have its perihelion? I looked online, but maybe it was one of these AI things. I don't know. Maybe its closest approach is actually a little bit later, but that should be its perihelion right there in October. So I don't know what the deal is with that. And we're not really going to spend the time to do a Google search on that right now. But either way, let's go back to today, the 23rd of October. Maybe it's already the 24th where you are. Effectively, this is where all these comets are. We're basically surrounded. We have 3i Atlas over there on the other side of the sun, but in the inner solar system, within the orbit of Mars. See that? Cut within the orbit of Mars. We have A6 Lemon above us right here. We have K1 Atlas to our right, and we have R2 Swan right now just to our left, but as we go forward, it's going to effectively be behind us. So this interesting kind of formation is set up around not only the inner solar system, but the Earth. And in general, and there's more comets than just this, but these are the 4 big ones, and this guy is not a comet as per the traditional definition for the solar system. It's quite a bit different. That is clear. So we can kind of get a sense of what A6 Lemon looks like with this graphic right here. And these comets are doing weird things. So check this out. We have Comet A6 Lemon. This was taken by the 2 twin telescopes on Tenerife, I believe, in Spain. This is recent. They did a whole campaign and got a whole bunch of imagery from September to October. And what they observed, and look at this. I mean, this is a beautiful comet. I mean, this is, if you go outside and you have good visibility and viewing conditions, you can see this with binoculars. You may even be able to see it in dark sky conditions with just your naked eye, especially if you have good eyesight, 2015, something like that, maybe 2020. But in general, if you have binocs, you can see this and the tail. If you have a telescope, it really pops out. Tons of people are getting photos of A6 Lemon, posting them on different forums, on Twitter and wherever. So it's really been an absolute astronomical darling for people because it's been just an incredible comet. Its tail here has been very active, rippling with the solar wind at a very fast time frame too. Like some people, they're out there looking at it for 10 minutes and they're seeing changes in the tail just in that short time frame. Here's the nucleus. This is actually quite large. they have noticed that this thing's actually spitting out jets. So there are two jets that they identified on this, two main jets. And this is a zoom in on this. This is the sun direction, okay? So the tail, of course, is going opposite of the sun, anti-solar right here. But look, right here we see jet A, jet B. So you can kind of imagine, because it's hard to see them on this, but there's these jets coming off of it just like that. And they also identified some other minor jets across the comet, but these are the two big ones that they identified, and they describe them. I linked the Astronomer's Telegram page for this, okay? So there's just some stuff that you can read there. The Astronomer's Telegram is like a fast way for people to release updates on, hey, we just spotted a nova explosion. Hey, big increase in gamma rays from this cluster, things of that nature. It's like a very rapid platform of information sharing among astronomers. So they posted that these jets have like a kind of a spiral motion to them. And these are the two big ones, but they're also scattered throughout. So clearly comets, just standard comets like A6 Lemon here, are weird, right? And they have some really crazy properties, right? It's this, and we've done some close surveys and stuff of comets. So we know that traditional comets in the inner solar system are made up of ice and loose rocky material, and basically it's just like a whole bunch of stuff slowly came together and combined. A lot of dust and gas. They're very low density, but they can be big. And so when they fly in close to the sun and you have that solar radiation just pumping out nonstop, especially during solar maximum like now, and the solar wind is strong, they cut through that ecliptic plane, they can off gas a ton, they can release a lot of dust, ice particles, and then a lot of that will get, you could say, plasmified, or rather you would technically say ionized, where a neutral gas will then get hit by energy, let's say like a photon, or maybe like it has this particle interaction, and now you have a whole bunch of charge carriers floating around, positive and negative, but plasmified is a bit more fun. These things get plasmified, and the moment you have plasma, you have a whole different ballgame, especially dusty plasma, because the dust grains will take on those ions and hold on to them. So there's less recombination occurring between the ions, because what often happens is you get, let's say like a photon to hit a neutral gas, and then it'll go like this and become ionized, but then it'll recombine, okay? And so there's this ionization and recombination rate, and we can measure this like in the upper atmosphere, different places. But in space, you get this ionization to occur, and then if there is dust present, and guess what? There's dust everywhere in the solar system. That's what we found. Different size grains, a whole distribution. Those ions often then go straight to the dust grains, and then the dust grains take on a charge. It can be either volts, like their potential, their electric field potential can jump up to like volts, even tens or hundreds of volts, maybe even thousands of volts. It can be quite significant. So if those ions attach to the dust grains, well, now you can't recombine as easily because a lot of the material for recombination is effectively gone. So you get this complex dusty plasma, and then the physics gets insane, and that's why it's called complex, because it's really difficult to model this stuff. And nowadays, a lot of the advancements in science are basically people just creating a model based on certain mathematical equations and then saying this is how it is. And it's like, well, math is not the universe. Math is awesome, but it's not perfect one-to-one. The universe is more than just math, but math is a great tool for understanding it. B, your model is certainly not like reality. And then to say that your model shows exactly what the reality is, well, that's just simply not the case. So we don't really know how these things are interacting with the larger electromagnetic field of the solar system, specifically the inner solar system. But we see here, it's a big object with a long tail that is made up of gas, dust, ice, and plasma. It's a complex dusty plasma along with some percentage of neutral gas and ice crystals and more. Space is cold, but we've also seen with laboratory experiments that, and also in space too, that plasma can form these distinct regions that are hot and cold, and they have these layers in between them, these boundary layers. They're called double layers. And so it can form like a cellular structure to it. And in fact, we hypothesize that there is a cellular structure to space. We see our own solar system reflecting that, with the heliosphere being effectively one bubble of more ionized plasma, and then outside in interstellar space where Voyager 1 and 2 are, it's colder and denser. And so there's this cellular structure of space. There's strong wind spheres, if you've ever heard of those. Some stars pump out a ton more radiation, especially the higher frequencies. So they create a very large radius around them of more ionized plasma, like a little local bubble. Those wedge up against each other. So we know that the electrodynamics of the solar system and interstellar space and at the galactic and cosmic scale is really, really wild. We can get, honestly, a pretty good understanding of some of this with some of our really wide view photos of like galactic clusters, because they create voids and then they create these strands, these filaments where all the galaxies cluster together. So by looking far enough out at big enough structures, it's almost like looking through a microscope at microscopic structures, because the universe is fractal. So some really cool stuff. When we have all these comets in the inner solar system, it's going to probably, right, can't say definitively, but this is what I think, it's going to change the electrodynamics of the inner solar system in a significant way, right? Is it significant? Is it not significant? That's kind of the question. Well, with enough of them and them being big enough and active enough, I think it's significant. So now we have this arrangement where, yeah, you already have the other planets, and the other planets already like alter these things. There's solar activity rhythms that are tied to Venus. We see that during superior conjunctions of Mercury, when it's on the other side of the sun from the Earth, we often get solar activity around those. Look through the record. You can just get the list of dates for superior conjunctions of Mercury, and then look at, the SDO imagery for the sun, and you'll see Mercury zooming along behind the sun in the chronograph, and then you'll see these big solar flares pop off. So like, you could do this yourself if you wanted to. I presented on the channel. Please subscribe if you want to stay up to date. You'll learn all this as you go. But if you don't believe me, just like pull up the list and look at it yourself, and you'll see that this is the case. So we already know the inner planets and even Jupiter and outer planets influence solar activity. That's already a pretty complex system that we're just beginning to understand in terms of planetary resonances and the effect on like the actual dynamics of the sun. The sun's a big unknown, and now you add in these comets, you add in Interstellar Object, 3I Atlas, well, things can get wild. So we had this second coronal mass ejection launched towards 3I Atlas. Let's check that out, because we had the first one and then we have the second one. So we have that right here. Here's our C3 chronograph. Going back to the 19th, we'll see this big, gigantic coronal mass ejection launch on the 21st near the end. Okay, so it's coming up and we're going to see it go like this. But look at all the activity already before that. Boom, shakalaka, there we go. Huge coronal mass ejection. We get another follow-up one right about here. There's that second one. And a little bit of uncertainty whether that was one big one or whether that was two, because you'll notice that there was a push here and a much bigger push there. Could have been lopsided. I kind of think it was probably one, but there's some evidence that maybe it was two. It's hard to say, but we know there's a big sunspot group right there. But there's that big one. It's the first one launched to 3I Atlas, has already hit it at this point in time. It's hitting it right now effectively. There's that second one. So we now clearly see how the sun has established communication effectively with this interstellar object, because it is blasting it directly. And this is what we've been forecasting on the channel for months now. So not rocket science, it's space science. And it has been not the most difficult to forecast. We keep it pretty simple here, and we just don't discount things that maybe go against like mainstream science narratives. Because we're most interested in what's actually happening. Now, when we had that explosion, actually there's two explosions, we had an increase in proton flux. So here we have our proton flux as measured by the GOES satellite at geostationary orbit. That's 5.6 Earth radii. These things are flying around the Earth, but they're in such a position that they actually stay locked and track one specific area. So these GOES satellites specifically, one of their main uses is to track hurricanes and weather for the western part of the United States, for the eastern part of the United States and the Atlantic, and then Japanese have one over Taiwan and Japan. And so we have a few of these, actually we have a lot of these geostationary satellites, but they pick up other things too. They're outfitted with a ton of different measurement devices. One of them is protons, so we can measure just the enhancement of these highly energetic positive ions, right? If you take a hydrogen, take off the electron, boom, you got a proton. And we see this first gigantic coronal mass ejection bumped up our proton flux. We nearly got to that threshold, the S1 level. I thought we would. I was surprised that we didn't, honestly. But I guess it wasn't aligned such for us to get a bigger dose. But if we're getting them here on Earth, and that explosion occurred effectively exactly on the opposite side, almost exactly the opposite side, think of about how much radiation flux 3I Atlas was hit with. So it's being irradiated. It's being irradiated right now just from the sun, and we have that going up dramatically for 3I Atlas because it was at effectively 10 to negative 7, 10 to negative 8 in its energy irradiance. Just how much energy it's receiving from all the distant stars nearby and from the cosmic radiation background. Then it's going up for its perihelion to about 735 watts per square meter. Massive, 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 like 10 orders of magnitude jump in terms of how much energy it's receiving just from sunlight. Going from basically zero sunlight from any stars all the way up to tons of sunlight. Then we have the solar wind also hitting 3I Atlas. And when it was in interstellar space, there is no solar wind. There's plasma, but it's just very low density, and it's just kind of slowly pulsating at certain frequencies, but it's not active and alive and dynamic like the solar wind is that it emits from the sun. So we have that happening. Again, 3I Atlas flying in along the ecliptic plane effectively means it's being pelted by that the whole time. We have these coronal mass ejections that launched, 2 of them towards 3I Atlas. Here is the NASA model for that. So this is the second one right here. And I don't have 3I Atlas plotted in this one, but it's right in this zone, effectively right here. So it's getting hit by that coronal mass ejection, that second one that launched last night. I posted about that almost immediately on Twitter X. So if you're there and you want to get these updates before I make a video, because I post interim updates there, then you can follow me. It's at Stefan Burns Geo. So STEFANBURNSGEO, all one word. Just type in my name and you'll find me. And just don't misspell my name or else it may be difficult. My name is right there on my channel, my YouTube channel. So we had that happen. And we see that second bump right there from that explosion, bumped up, and now we've kind of come down. This is a logarithmic scale, so it looks like we're close to baseline. We are definitely closer, but we're not down to where it normally is, which is about 0.15. So our greater than 10 mega electron volt ones are still elevated, but a little less than double. So this hasn't been that much of a storm, but like a radiation storm, has not hit the S1 level, but it's more energy received than we would have because these explosions have all been happening on the far side. The fact that we got pelted with this is pretty remarkable to begin with. So you may have been feeling that, and this in general just means more energy here on Earth because this interacts with the atmosphere, gets absorbed. And I know we have, I think it's Hurricane Melissa. No, it's Tropical Storm Melissa right now, but forming in the Atlantic may be a big one. This certainly wouldn't help that, right? It's just adding more energy to the system. Now we have some more weird things, right? So NASA, some of the weird stuff that NASA's been doing. Well, here we have our imagery from stereo ahead. It's ahead of Earth's orbit, and this is the Sunspot group in particular that has been the culprit of these 2 big solar storms. But look right here. We're going to see around 2000 this gets clipped. Watch the timestamp and watch this though. See how it just jumped forward 3 hours, and now we see the aftermath of that big explosion, and the other one was roughly at the same time, just 1 day ahead. So we're going to watch this go forward. We still see how active this sunspot group is, but when we get close to that time window, we'll notice a big jump on this starting pretty soon. And it's right about here. Oh, and now it's noon and we missed the other explosion. Okay, so if I go back right here, now it took some time, back to like 2 or 3 hours or even 4 hours for this stuff to come in. But you see that it was the explosion. The first one was right about here. The second one was right about here. And for some reason, this data was clipped for both of those. Why? I don't know. But they were taking images almost like every 3 minutes, as you can see right here. This is just the raw data I downloaded. And then maybe we still need it to come in. Maybe there's like a time delay. I'm not exactly sure because this is going up to the latest imagery possible. But why they clipped that out, I don't know. Why they clipped out the second one, I don't know. But there have been so many times where I've gone to look at something on the coronagraph of some big explosion or from stereo A or from whatever, and it's just like missing. And there's no reason why, no explanation. It's very bizarre. So, not saying it's conspiracy theory, but it happens so often that it's just really like beyond bizarre. It's also just frustrating. It's like you want to see that explosion so you can better accurately forecast the space weather and understand what's happening. But like, oh no, let's just clip out the most critical 4 hours. Yeah, I don't get it. But it's something that's bizarre, and we can add on to the bizarre also with the fact that we still don't have our imagery from the NASA Mars Reconnaissance Orbiter, and specifically we want the high-rise imagery because that's going to be high resolution. And they even put a note up here. You know, before they had the website saying no websites will be updated during the government shutdown because we don't have the staff. But then all of a sudden they have the staff to put up this, which is like, it's just so stupid. Any images of the interstellar Comet 3i Atlas are considered NASA-wide news because the federal government shut down. Communications of NASA news has been suspended. So that's what they're saying. And if you go to, I think it's Highview. Let's see if this is it. No, it's not Highview. Oh, it's Catalog. If you go to Catalog, you see that we are still effectively missing data from high-rise since the government shutdown began, because these are all the latest, at least according to this website, October 1st. It's now the 23rd of October here on the East Coast of the United States of inadequacy. So not us, the people. I think we are grooving. We're fine. We're chilling. It's the elected and mostly non-elected officials that need to go. So, so we have earthquake activity has been quiet for the past few days. I would say nothing crazy. I have not had an earthquake watch in effect because of a variety of factors. None of them have indicated that we should be concerned about earthquakes, other than all these comets and 3i Atlas being close by. But the space weather conditions, at least, have not been favorable for high magnitude earthquakes. And if we go to our 7-day view, we see that that has effectively borne out to be true, though we've had some 5.9s, but nothing over 6. So that's kind of a good threshold, in my mind at least, for things to be over magnitude 6. So if you go to largest magnitude here, we see the biggest one that we had was back on the 16th, magnitude 6.1 Philippines. We see that one right there. Then we did have this 5.9 recently, Costa Rica. That was yesterday, early morning Universal Time. 5.9. I mean, it's a big earthquake hitting near San Jose. I think they may have felt that there. Costa Rica is a beautiful place. Also a 4.3 aftershock, but not a magnitude 6. We have this magnitude 5.8 for the Philippines. That was on the 20th. 5.6 in Kamchatka. It's still very active, anomalously so. We are waiting on there to be a big earthquake again in this zone because it has been building up. So that is one of the forecasts I have out, that at some point we're probably going to get something greater than magnitude 7.5 in this zone. May not happen, but there's been this ping pong effect between South of South America and Kamchatka, because these are nearly exactly antipodal, meaning they're on opposite sides of the Earth, almost exactly. So we've had a lot more energy released up here in 2025 than down here, and we've been having, but that said, we've had 3 earthquakes there, 7.3, 7.4, 7.5 in that order, getting stronger on a fault system that basically no one really knew about, right? I mean, this zone there, it's not like on a mid-ocean ridge, it's not on a subduction zone, but we've been getting big Mag 7s there. So there has been a lot of seismic activity this year, but the past week has been quiet. And so we're probably in that lull before the rise. I would say now with this video, we probably should expect there to be some big earthquakes going into the rest of October. So the final week, going up to Halloween. I don't know about November. We'll cross that bridge when we get there, but probably we're going to have some significant activity sometime in the next 7-8 days. Magnitude 6.5 or greater, I would say, would be something. I wouldn't be surprised by magnitude 7+. And we have our space weather model for what's been happening with these coronal mass ejections, and this is set for Venus. So Venus and 3i Atlas are really close together right now. Now 3i Atlas is, again, it's perihelion, it's on the 29th. Its closest approach to the sun on that day will be 1.36 astronomical units. Venus is closer than that. So 3i Atlas is more like out here. But in general, it's about like right here or so. Now this model shows a few things. It does not show that second coronal mass ejection that was launched out. So it shows everything up until that moment. You see 1, 2, this is a gigantic one there. We also see a very faint third one. They haven't modeled that second one that occurred about 24 hours ago now. So, and that's what they wrote in the little blurb underneath this. But this model was run today at 10 a.m. Universal Time on the 23rd. But we see if 3i Atlas, again, remember it's right about here. This is Earth's orbit, right? That's Earth's orbit. This is stereo A, our probe. So you can see why that probe is able to see those sunspots even though they are behind this, the sun from the Earth's perspective, right there on the far side. Stereo A is ahead so it can peer around the corner effectively. But then why they clipped out that data, I don't know. We already talked about it. So Venus is right here. 3i Atlas is right about here or so, maybe more like right here. And you see it's getting hit by that first coronal mass ejection and also by that second one. Look at how high the plasma density spiked for Venus. This is the plasma density and this is the velocity. So it's a big impact and it's hitting 3i Atlas effectively right now. If not, it's like already passed and that second one is now coming. So communication has been established between the sun and 3i Atlas. Again, across all those different energetic pathways that I described earlier. Solar irradiance, solar wind, plasma waves, these coronal mass ejections, and also the relativistic proton flux and the ion flux from the explosion itself. 4 ways. Really big stuff. Sunspots are about 115 at this moment in time. You can pull that up really quick just for you to see what's happening with our sunspots. We're about to do our 3i Atlas live question and answer. So if you have a question, save that for the question and answer. Or if you attach it to a super thanks, I will answer it. I have the ability to go through my list of super thanks today. So I can do that. And here we have our sunspots. And we see that we were hovering in this like 170 zone for a while. We dropped down here. This was the beginning and middle of October. That's like the 9th specifically right there. A big drop on the 9th. And we went back up, but we did not soar back up to 200 or anything like that. But it has been kind of holding more steady than not. Like often we get these really big troughs and then start to go up. This one was kind of rapid and then now it's falling off for about 100 and 100. Looks like this latest count right there is saying 100. So sunspots are about 100. We are just entering, we're like solar maximum descending phase. We're right in that zone effectively. So that is what's happening with our sunspots. And we have all these comets flying in and surrounding the Earth. So 3i Atlas is not the only story here. It's certainly the most interesting. It's the one that's filled with the most misinformation floating around. Tons of people just making stuff up on 3i Atlas. It's a serious problem. And I'm just noticing a lack of due diligence. Like people are reporting things, they're not linking the source article, they're not linking the research paper. The person may say Dr. Jerry Novada claim that they observed this repetitious radio pulse, but then you type in Dr. Jerry Nevada and they don't exist. So people are just making stuff up. and that's why they're not putting these links in. So just like a quick like FYI, like if you are researching this or you're seeing these things, A, don't believe headlines, okay? Because almost all of them are like fake as it relates to 3i Atlas. B, read the thing with some skeptical kind of nature, because there's probably, if it's misinformation one, could be quite wrong. C, check the sources. If you check the sources, that's how you find out it's fake. 9 times out of 10, there won't even be link sources. That's a red flag, right? Check for like the red flags. If it's written by AI, like AI is very easy to identify in terms of the written speech, because it's very much like, it's not this, it's actually that. Almost all the ChatGPT stuff, it has like this, it pushes and pulls on you that way. So if you read that it's written by AI, just toss it out the window. AI is great. It made this video right here. That's super cool. But in terms of it being like an accurate news reporting source, it's not. That's not what it's going to be good for in the future, I don't think. At least right now it's not. So figure out what the red flags are, like learn how to spot these red flags, and then move forward with that. I also want to show you this really quick. This is interesting, okay? Now, I want to preface that I'm not, a telescope expert. I do have plans to open up an observatory at some point of my own, but I don't have it yet. But I do have some ability to think logically, and I'm interested in facts and the truth. So I see through a lot of things, though I'm not perfect. I'll never state that I'm perfect, okay? So here we see a telescope showing Betelgeuse in focus, then out of focus, and then back in focus, okay? Now, this is not about Betelgeuse. There's a lot of misinformation floating around about Betelgeuse having, like, it's exploding tomorrow. We don't know, okay? This is just showing the focusing of a telescope. Watch what it gets created. That's Betelgeuse out of focus, okay? That's what it looks like. And now it's back in focus and you get the star, okay? These telescopes require a lot of fine tuning. And these images that we've had of 3i Atlas, like from the big telescope arrays, okay? Like the big daddies, where like it's multi-million dollar, like 10, 15, $100 million arrays, okay? Huge mirrors and lens and such. They're taking long exposures, 30-second exposures, and stacking it like a dozen times, 24 times, 100 times to get these images that we've had of Interstellar Object 3i Atlas, okay? Because it's very faint, it's very dim. So its magnitude at times is like 14, 13, 12. Its final magnitude, this is like its brightness, was around 10.8 at the highest. That was registered right at the beginning of October. And so you can't pick up something that is near the sun if it's super dim and the sun is super bright. Doesn't matter what sort of filters you put on it, it's effectively like looking at a little tea candle, one of those little tea candles behind like a flood lamp, okay? You're not going to see the flood lamp shining this way, the tea candles, you're not going to see it because the flood lamp is so strong. That's the sun. So a lot of these things floating around, right? Like, oh, we imaged 3i Atlas on October 19th or something like this. It's not possible because it's simply like you can't do it. And if you could, all these big telescope arrays, which are trying to observe this thing, and there's a lot of people really fundamentally interested in, or the third ever interstellar object observed, they're going to want to know. So what their motivation is to understand what the heck it is. Other people's motivation can be, oh, I just want to make a quick buck or something. So they can play with things like the focus to make it look like you're seeing something. Whereas this big telescope array needs, 50 different stacked exposure shots to get it. Well, you're not just going to see 3i Atlas when you have the glare of the sun from a live camera view without any stacking and processing of the data. It simply is not possible. So this is what it looks like when you're on a star. You change the focus of a telescope and then you change it back. And maybe some of you recognize what this looks like. But in general, you can make up a lot of things, and it's like a magician, right? A magician won't tell you their secrets. Thing is, you don't need to be a magician to just like break the spell and show the trick if you know what the trick is. So you don't have to be the magician. You don't have to be the an absolute astronomy expert if you know some of the deal. And I'm quite good with cameras and stuff, so I'm not totally clueless. There is stuff on the website, earthevolution.com. I mention it now because it just popped up. We've been selling a ton of spirituality. We have the Interstellar Atlas 3i shirt here, small to double XL. A whole bunch of things on the website, all organic herbal tea blends, as well as merch. You can check that out if you like. Linked in the video description. A lot of you have been buying stuff recently. Thank you all so much. You're going to love it. Super high quality stuff. The best, the best, the best. All the shirts are natural fiber like cotton or linen cotton blends. The herbs are all organic, made and mixed ourselves. The crystals are the highest quality you can buy. Super optical clarity, as you can see. So we don't mess around with any nonsense here. Super good stuff. And if you're interested in this, now's a great time to pick it up, earthevolution.com. Now there's one more thing that we can talk about, and that is that the IAWN, the International Warning Network, the International Asteroid Warning Network, has put out a call for people to observe Interstellar Object 3i Atlas from November to December, which is when it's starting to be viewable again. And a lot of people that are taking that as a sign that it's aliens 100%, because, well, it is. Well, it's more so, it's two things. A, it's a rare opportunity to observe a interstellar object. So it makes sense that you mobilize the community however you can to get as much information on this thing as possible. That's A. B, it does represent an attack vector. We don't know what it is. So while the alien thing is like the least likely in my mind, it is prudent to put out an alert like that so we can be watching our skies to a greater degree. Now I'm going to be releasing a video on 3i Atlas. I think I'll release it tomorrow from like an alien perspective, okay? Which I think a lot of you guys are going to find really fascinating. It's speculative, but we're going to go down that path. And like, if it is aliens, what would actually be logical and not just, aliens, like, let's say they're coming into the solar system and 3i Atlas is it, okay? They're not going to go straight for Earth because it'd be like an immune system reaction. At least I don't think they would. They have one single little rock flying around. That's their ship. You wouldn't be able to do it. 8 billion people would freak out and like rip them to shreds. Like eventually, like they wouldn't be able to do much. But in terms of colonizing the solar system, right, you're not going to go straight to Earth. You're going to go somewhere else. Now, maybe you would like launch 1 or 2 ships to go investigate the Earth while you're hidden by the sun. You sneak up, like you do like a sneak attack, but you're not going to probably try some sort of invasion. You need a fleet, okay? Technologically, maybe we're not that advanced compared to some hypothetical interstellar colonizing ETs, but there's a whole bunch of us here. So it's like an immune system reaction. I don't think that we would tolerate it. You'd have to come in with some pretty overwhelming force. But everything as it relates to aliens and ETs is basically in that realm of speculation. So it does make sense though, like we don't know, these things are all possible. It's a super low probability, but we should like be attentive to this. And so putting out that alert with the International Asteroid Warning Network to observe 3i Atlas from November to December, to A, gather as much information on this unique opportunity, and B, to keep like a watch on our skies. So if something weird does happen, like we are as prepared as possible, that all makes sense. But I don't think it's like, it doesn't have to be a guaranteed mission of we're being invaded. So that's again like how people spin the story. There's a lot of ways to look at it, but it just makes logical sense to do something like that. So that's the other update I had for you. So I'll see you all in the next video. Wishing each and every single one of you well. Please take care of yourselves. Get outside, do some grounding, go for some walks, eat good food, have some fun, meet up with friends, do all the things, be a good person, do a good deed every single day, and I will see you back with the next video. Thanks so much.